All right, question number 25. This is adding and subtracting. The key is common denominators. My camera is having a hard time focusing, so I'm going to try my best to get it back into gear. So I want you to notice for number 25, they are common factor denominators. So just add or subtract the denominators. Just keep bringing it in as close as I can. Man, still doesn't want to. All right, I'll do my best. So the denominator stays the same, and then you add the numerator. So you get 2m plus 2. But at this step, you need a factor. So we're going to factor out a 2, and then 2 goes into 20 10 times. So your final answer is m plus 1 over 10m squared. All right, number 26. To subtract, we need common denominators, which we do. So you write that common denominator. Now you subtract. So 4 take away 1 is 3x, and 2 take away 2 is 0. We don't need it. And now you simplify it. So 3 goes into 15 5 times. Subtract the exponents. So x makes the x cubed into a squared. So all that's left over is 1 over x squared. Number 27, we have common denominators. So add the numerators. That's 2k minus 7. And when I have that, it's a good habit to try to factor it to see if something simplifies. So here nothing does, so I factored out the denominator. Nothing simplifies, so that's the answer. Number 28. The common denominator, 3v squared plus 7v take away 20. Subtract the numerators. 3 take away 1 is 2v. Be careful here. When you subtract negative 1, it's plus 1. And then I need to know, is that it's factorable. That's negative 60. And 12 and 5. This just takes a moment to do. So now when I factor it, I just need to see if there's a common, which there isn't. 3v take away 5, v plus 4. So there is no common factor and it's done. But I do need to factor it to see if it can simplify. Number 29, we have common denominators. So we write the common denominator down. And then we subtract. So 5n subtract n is 4n. And negative 4 subtract negative 4 is 0. And then I look at the denominator and I factor it. So that's positive 1 and positive 2. And nothing eliminates and it's done. Number 30, we have common denominators. We add, so that's r plus 12. I'm going to factor the denominator and see if something eliminates. It's not, but it's good practice to be able to factor it and see if anything eliminates. So there's my answer. Number 31, these are not common denominators. So these are a little more challenging. So the first thing I look at is, are the denominators prime or are they factorable? So these are both prime. And now, how do I make common denominators? So I'm going to take the other denominator, m plus 4, and I'm going to multiply top and bottom times that m plus 4. I'm going to do the same thing on the right side. I'm going to take m subtract 2. And I'm going to multiply the numerator and the denominator by m subtract 2. Now, order doesn't matter when you multiply, so these are common denominators. So now I have common denominators. And then I'm going to distribute. That's 3m plus 12 and 6m squared minus 8m. And then your last step, 8m. 6 times 2 is minus 12m. And now combine like terms. So we have 6m squared, 3 take away 12 is negative 9m, and then plus 12. I'm trying to see if it's factorable or not. I'm going to continue up here. I'm going to factor out a 3. It's not factorable. And so what I'm looking for, what I'm like 2 times 4 is 8 and negative 3. And there's no numbers that multiply to 8 and add to negative 3. So that's done. All right, number 32. I need common denominators. So step 1 here is to look at the denominator. In fact, I'm going to simplify this to 1 over a. That's going to make my life easier. And then this denominator, I'm going to factor out. So they both have a 3a in common. Actually, that's not going to be helpful now. So factor out 3a, and you have 3a minus 2. And again, I'm trying to simplify this as best I can, but I need the denominators to be the same. So this denominator, simplifying the 3 wasn't helpful because I need that 3 for a common denominator. So I need a 3, and what else does it need is 3a minus 2. So I take 3a minus 2. Now the denominators are the same. You take that also in the numerator, 3a minus 2. Remember there's a 1 here. Now the denominators are the same. I'm going to distribute, and I'm going to combine like terms for the numerator. So when I multiply, that's 9a minus 6 minus 4a and then the last step, 9 take away 4 is 5a minus 6, and then the common denominator. Obviously, this is the most challenging part of rationals, is adding and subtracting when you have to make common denominators and then be able to combine it together. All right, number 33. I need common denominators. First step is to factor, if you can, the denominator. So I'm going to factor out a 2. And then I'm going to try to make them the same. So if I need to make them the same, I need to multiply this by 3a top and bottom. And I need to multiply this by 2a plus 5 top and bottom. Now comes the work of multiplying and combining like terms. So we have a 3a times 2. So that's 6a, a plus 5. That's our common denominator. And if I multiply this, this is 8 times a and 8 times 5. And now I can add it up. So that's 20a plus 40. I can still factor out a 20. And 2 goes into both evenly. And there's your answer. So it's 10 and this, and 3a and a plus 5. Done. Number 34. So to get common denominators, I'm going to multiply top and bottom by b plus 4. And then for the second fraction, I'm going to multiply top and bottom by b subtract 2. That will make the denominators the same. So I have 6b squared plus 24b subtract 2b squared subtract 4b. And we have that one common denominator. which is b minus 2 and b plus 4. Combine like terms. So 6b squared take away 2b squared is 4b squared. And 24, when you subtract a negative, you're adding. So that's 28. I'm going to factor this out. So you can factor out a 4b, and you're left with b plus 7. That does not remove anything in the denominator, but now it's in factored form, and you can see that it's prime, and there's your answer. All right, two more. 35, I need common denominators, so I'm going to multiply by k plus 2, top and bottom. And k subtract 3, top and bottom. So now we have a common denominator, k subtract 3 and k plus 2. In the numerator, 2k squared plus 4k subtract, I'm going to use parentheses, 4k squared subtract 12k. So now we're going to combine like terms. So we have our common denominators. So 2 subtract 4 is negative 2k squared, and 4 subtract negative. So we're adding. When you subtract a negative, so that's 4 plus 12, that's 16. And then if you want, we could simplify that, maybe just a little bit, factor out a negative 2k, and you have k minus 8. And now it's fully factored, and it's prime. So there's nothing that eliminates. All right, last one, number 36. We're going to factor out, I'll do it here. We're going to factor out a 2. That's m plus 2. And I'm going to create common denominators. So they both have a 2, but this needs another m. So I'm going to multiply top and bottom times m. This one needs an m plus 2. And now we have common denominators. So we have 2m, m plus 2. That's a common denominator. And then in the numerator, we have m squared plus 6m. And we have 3m plus 6. Because we're adding, it's a lot easier to combine them together. So we're left with m squared plus 9m plus 6. That is factorable. Two numbers that multiply to 6 and add to 9. No, is it? No, it isn't factorable. If it was 6 and 9, it'd be factorable. That's it. All right, Mr. G Math over and out. I'm proud of you for doing your work and not giving up. I know it's not easy to keep practicing and keep doing your best. Till next time.